Now let's look at how to write equations from roots. So here I have two wonderful roots. One root is at 7, 0, and the other root is at 0, 0. So if you remember, if I go to the factored form, that's the key, we're going to use the factored form of the equation. Factored form, you take each root and plug it in. When you plug it in, you're going to change the sign. Now the only thing this wouldn't apply to is 0, because 0 doesn't have a sign. So we're just going to take it and plug it in. My first root is at positive 7, so we're going to make it a negative 7. So I have x minus 7. My second root is at 0, so we just do x minus 0. Okay? Well, x minus 0, that's just x. So I'm going to rewrite this as x times x minus 7. Okay? Now I want to get this in standard form. This would be factored form. We're going to get it to standard form by multiplying or distributing that x. So the standard form of the equation would be x squared minus 7x. And that would be my answer in standard form. So now let's look and see what would happen if we had fractions. Fractions are really, really easy, but in order to understand the fraction, let's do a really quick example. If I were to solve 2x minus 5 for x, what would we do? Well, we'd move the 5 over, so we'd add 5 to both sides, right? And I'd get 2x equals to 5. And now I got to get rid of the 2, so I would divide by 2, divide by 2. And I get x equals to 5 halves. So you'll notice, where is the 5? Well, the 5 changes signs and is on top. And the 2 from the original problem statement is on the bottom. Same sign on the bottom. So when I work backwards, when I'm given the fraction, and I work backwards, the bottom is going to be first. It's going to be in the front, just like it was right here. Whatever's on top is at the back, and we have to change the sign. This one's positive, so it's going to be negative. Now let's do our second root. Our second root's at negative 3. So remember, we also have to change the sign for the negative 3. When you change the sign, it's going to become positive. And now we are ready to go to standard form. Remember standard form, we're going to do double distribute or foiling. So I would have 2x times x, that gives me 2x squared. 2x times 3, which gives me 6x. Negative 1 times x gives me negative 1x, and then negative 1 times 3. Again, we combine like terms. When we combine our like terms, we get 2x squared plus 5x minus 3. And this is our equation in standard form. Now let's do something that's just a little bit more intense. What if we're given imaginary roots? Now remember, with imaginary roots, every time you have the plus, you're going to have the minus. So you automatically are going to have this case as well. Okay, so we're going to plug each one of these roots into our wonderful standard form. Now I'm going to, since there's already parentheses, I'm going to put a big huge bracket to indicate. So I'm going to have x minus the first root, which is 2, plus I, okay, and then I'm going to have x minus the second root, which is 2, minus I. Alright, now we are going to go ahead and do like we would normally do, except I need to simplify this a little bit more. So I'm going to distribute the negative 1s. When I distribute the negative 1s, I now have x minus 2 minus I, and then x minus 2 plus I. Okay? Now if I look at this really, really closely, I'm going to compare, and I notice that the x minus 2 part is the same. And then I've got this I over here. And then I look at the signs in between. The signs in between are opposites. So we're going to treat this as the difference of two squares. Working backwards, that means I should have the x minus 2 squared and then the I squared. Okay? Now the plus and the minus, so positive times negative gives you a negative sign right there. Okay? And now we're going to actually FOIL this out. So I'm going to write it twice, x minus 2 times x minus 2, and then we have minus I squared. And the interesting part, go ahead and FOIL that out and get x squared minus 2x plus 4. This is where it gets interesting. Did you know? Alright, so negative 1 equals to I, right? So I squared is that square root negative 1 squared, which is simply negative 1. So this becomes negative 1. So you're going to have minus a negative 1. So when you subtract a negative 1, you're now adding. So when we combine our like terms, let me underline everything, so I have like terms here, like terms there. Alright, we're going to get x squared minus 4x, and now I have 4 minus a negative 1, which is plus 5. And that would be my equation in standard form with a complex root or an imaginary root.